Question 1, Review 1. Draw the angle 150 degrees. Whenever we're drawing an angle, remember 0 is always off here to the right, and we're drawing the angle, if it's positive, in a counterclockwise direction. If it's a negative angle, then we move in a clockwise direction. So 150, our 0 is here, and now we're just going to 150 degrees. So we can see that our answer here would be D. Okay, next question is to draw an angle of 7 pi over 6. So we look on our reference sheet, and on this page you'll find common angles that you'll see on the unit circle. So here is a circle that is divided into pi over 6's. So again, since it's a positive angle, we're going to go counterclockwise, and we're just going to count 7 of these slices. 1, 2, 3, 4, 5, 6, 7. And that matches with choice A. Number 3, convert the angle in degrees to radians. So on our reference sheet, we're going to look at the degrees to radians formula, and it says multiply by pi over 180. So we take 30 degrees times pi over 180. And then I'm going to reduce to lowest terms. So that gives me 3 pi over 18. And then if I reduce that one more time, I get pi over 6. Okay, next up we have question number 4. Convert the angle in degrees to radians. So our degrees to radians, 179. So I'm going to do the same process I did before. The difference is now it's asking us to do it as a decimal. A rounded decimal. So I'm going to multiply this by pi over 180, and I get 179 pi over 180. And now this I will do on my calculator. Alright, so 179 times pi divided by 180. Okay, and then it says round it to 2 decimal places. So I got 3.124, and that 4 says leave the 2 alone, don't round up. So this will round to 3.12. And we can see over here is if I went to 179, okay, here's 170 degrees. Okay, so, and this is the radians. So you can see 179 is going to be a little bit over 3.1 radians. So my answer makes sense. Convert the angle in radians to degrees. So I go over to my formula here, and now I'm going to use radians to degrees. So I've got 2 pi over 3 times 180 over pi. Right? So these pi's will cancel. I can do some reducing with 3. 3 goes into 180 60 times. So 2 times 60 is 120 degrees. And I can see on my chart here, there's 2 pi over 3, and there's 120 degrees. Question 6. Convert the angle in radians to degrees. So we're using our same formula, but this time we're going to be using the calculator because it's asking for a decimal rounded to 2 decimal places. So 2.06 times 180 over pi. So I do this on my calculator. My numerator, 2.06 times 180, and then I'm going to divide that by pi. Notice how I put it in parentheses so that it'll multiply those two numbers on the top first, then divide my answer by pi. And we get 118,029. And when I round that to 2 decimal places, the 9 tells me round the 2 up. So this is going to round to 118.03. Question number 7. Find the length S of the arc of a circle of radius 12 meters subtended by the central angle 1/3 radians. Alright, so if you look over here for arc length, when we see the word subtended, that just means that's the arc that gets cut off when we draw an angle. So we're going to draw an angle that is 1/3 of a radian. So 1/3 of a radian is about 0.3. So if you look over here, what we're actually going to end up drawing is a picture. See, about 0.33 is 1/3. Okay, so it's going to look something like this, roughly. Okay. So we want to find the length of this arc right here. And we're told that this opening is 1/3 radians. So we'll take our formula from our reference sheet. Arc length, which we refer to as S, equals the radius times the angle, and the angle, if you look at this, the angle must be in radians, and it is. It's given to us as 1/3. So my radius is 12. My radian is 1/3. So I multiply that out, I get 12/3. So my answer is 4, and we are measuring in meters. So this is going to be 4 meters. That's how long that arc is. From here, if I went from here to and stop there, that would be 4. I would travel 4 meters if I was running on this, let's say. That distance is 4 meters with a radius of 12. Eight. Find the area of a sector of a circle of radius 50 centimeters formed by the central angle 1/3 radians. So we got a similar situation to what we had earlier. That we've got a third of a radian. Alright, in this case it's asking us to find area, so we're going to use our sector area formula. This is now asking about how much surface is that sector covering. So that sector is like the shape of a piece of pie. Alright, we're told the radius is 50. And the angle is 1/3 radians. So theta is 1/3. The radius is 50. And my formula is the area is equal to 1/2 the radius squared times the angle, which is 1/3. That's our area formula for our sector. Now we simplify this. So I'm going to have 1/2 times 1/3, and then 50 squared is 2,500. And when I multiply that out, let's see, I can do some reducing. 2 divided by 2 is 1, And 2,500 divided by 2 is 1,250. So I end up with 1,250 over 3. And this one says round it to 3 decimal places as needed. So we're going to divide this out on the calculator. So this tells me to round it to 3 decimal places when I divided it out. So I look at this 6. And that's going to tell me to round this 6 to a 7. So this 6 tells me to round that up. And now my answer now will be 416.667. And my label on that is square units because we're talking about area. Question 9. Find the central angle which subtends an arc of length 25 feet of a circle with a radius of 48 feet. So we know our radius here is 48 feet. We know the length of the arc is 25 feet. And the question is asking us to find what's this angle. So we're going to use our arc length formula because there's our key on which formula we're going to use. We're given the arc length. So my arc length S is equal to the radius times the angle. So I fill in what I know and then I solve for what I don't know. So S is 25 feet. R is 48 feet. And now I'm going to solve for theta. So I'll divide both sides by 48. And I get 25 over 48 is equal to my angle. And the instructions say type an integer or a decimal rounded to 3 places. So we're going to divide that out on the calculator. 25 divided by 48. And we're going to go to 3 decimal places. We'll round that now to 3 places. The highlighted 8 tells me to take the 0 and round it up. So I'll round to 0.521. And this is radians because it's asking for the angle, and these angles are measured in radians. Last question. Okay, the area of our sector we're told is 9 squared meters. So this shaded piece right here is 9 square meters. So I'm going to take out A in my formula, and since this is referring to area of a sector, I'm using my area formula over here. So that's going to be 9 1/2. The radius is 6 meters. And I don't know the angle. That's what I'm trying to find. Okay, now we'll do the math here. So I do my exponent first. That's going to give me 36. So I have 1/2 times 36, which is 18. And now I'm going to divide both sides by 18. And I get theta is 9 divided by 18, which is 0.5 rads. And that's my angle. Half a radian, but the instructions say to type in a decimal. So I'm typing in 0.5, and there's no need to round it because it's an exact. And that is our first review.